When someone is injured in a futuristic sci-fi movie, high-tech medical devices and machines often help to rebuild and heal the human body. We might see a hovering scanner or a robotic arm repairing wounds by printing new parts. Such seemingly sci-fi technology is actually under development today. In this video, we explore how 3D printers are making it all possible. 3D bioprinters already exist using bioinks made from human cells. This means biological structures, such as bones or cartilage, can be printed. Today, 3D printed titanium is being used to replace human body parts, and next-generation prosthetics can be connected to the internet. Imagine a prosthetic arm downloading a program to instantly learn how to play the piano, allowing humans to essentially download new skills. Could we soon see prosthetics that grant humans super strength and speed? As 3D printed parts and robotic prosthetics become more advanced, and as humans incorporate more artificial components, will we need to redefine what it means to be human? There's been a lot of talk about Neuralink, Elon Musk's company developing brain-to-computer interfaces. Their recent demonstrations measured brain activity in pigs, with the goal of solving brain and spinal problems. Although it sounds like science fiction, a do-it-yourself approach to brain-to-computer interfaces is already possible today, with the help of a 3D printer. OpenBCI is an open-source brain-to-computer interface anyone can 3D print and build at home. The device's structure is 3D printed, and electronics are then fitted onto it. Such EEG headsets measure basic concentration, attention, eye, and facial movements. With enough dedication, people can build their own systems to control robotics and prosthetics with their thoughts alone. Prosthetics are among the most common areas where 3D printing intersects with human healthcare. Today, these prosthetics are becoming more advanced. Open Bionics, for example, creates prosthetic arms using 3D printing. Their Hero arm detects the user's muscle impulses through electrodes on the skin, translating them into movements of a robotic hand. Because it's 3D printed, it's easier to create various designs, and children can have new arms printed as they grow. Ubionic also 3D prints prosthetic arms, similar to Open Bionics, and goes a step further by offering 3D printed augmented arms. They sell materials and instructions so users can print and build their own robotic limbs, or even human enhancements. They are developing advanced control methods, such as harnessing electrical signals from the brain to operate the devices. There are open-source 3D printed arms available through the eNable community. Volunteers worldwide can input a child's arm measurements into a computer, resize a 3D model, and print it. Over 100 countries have volunteers ready to print and assemble these arms. The designs work best for users who still have a functional elbow or wrist. They flex their elbow or wrist to open and close the 3D printed hand. This simple function can drastically improve a child's ability to perform essential tasks like feeding themselves. Hands are a major focus in prosthetics because a functional hand can be truly life-changing. For instance, Naked Prosthetics creates MCP drivers, finger prosthetics made from 3D printed stainless steel and nylon polymer, and they can be customized depending on how many fingers need replacing. Connecting 3D printed human parts to the internet could make them even smarter. The Italian startup Rejoint builds 3D printed cobalt and chrome knee replacements. They use sensor-equipped headbands and socks to measure how a user's weight and movement load the knee. Data is sent to the surgeon to optimize the 3D printed knee's performance. Soon, prosthetics might allow humans to enhance themselves with stronger, faster limbs. Eventually, these advanced parts could surpass natural ones and perhaps be programmed to perform specific tasks. In the future, people might even volunteer to have their limbs amputated or organs replaced with more advanced, longer-lasting, and more powerful versions. We already use 3D printed titanium alloys to replace or fix body parts. Titanium's bone-like porous structure allows artificial implants to integrate seamlessly with the body. For example, we have 3D printed titanium implants for spinal conditions to prevent paralysis. Emerging implant technologies is one company producing such advanced implants. Another way titanium helps is in bone implants like knee and hip replacements, which can wear out after 15 years. Titanium and polymer implants may never need replacing. There are already 3D printed titanium rib cages for patients who have tumors in the chest wall. After removing parts of the chest wall or ribs, the 3D printed replacements protect vital organs. The polymer component adds flexibility, while titanium adds strength. In the UK, a 3D printed titanium cage can rescue a severely fractured shin that would otherwise require amputation. The cage holds bone fragments together, encouraging them to fuse and allowing the patient to keep the limb. 3D printing is also revolutionizing simple solutions like casts for broken limbs. 3D printed casts allow precise, water-resistant support and can include rehabilitation modules to stimulate muscles electrically. This prevents muscle atrophy and could reduce healing times from 10 weeks to just 7. Bioprinters can even print living tissues using bioinks derived from human cells. They can produce bone, cartilage, and other structures. Complex organs like livers and kidneys are within about 10 years' reach. Already, Wake Forest School of Medicine has printed bladders, and other researchers have printed thyroid glands, liver patches, and beating cardiac tissues. Creating functional biological parts requires bioinks made of living cells. There are bioinks for bone growth, liver growth, muscle fibers, arteries, bladders, intestines, skin, lungs, and more. Some bioinks can conduct electricity like nerve cells, enabling them to print muscle tissues that respond to electrical signals. Lastly, consider Marie, a life-sized 3D printed human body developed at LSU. Made from bioplastics and filled with water to mimic different body types, Marie helps scientists measure radiation exposure, optimizing cancer treatments. Eventually, nanofabricators will let us 3D print anything at the molecular level, turning raw materials into finished products. Science historian James Burke predicts this could be common by 2042. As we enter this new era, the line between human and machine will blur. High-tech prosthetics and bioprinted organs will change who we are and what we can do, forever altering the definition of being human. In the next episode of Venture City, we'll look at self-driving cities and how they'll change our lives, from the roads we walk to how we build our homes. Hit subscribe and thumbs up so you won't miss it.